I'm Sangwoo. I'm working as a CTO at MakinaRocks. So today I will talk about like how should we tackle the task of building model training pipeline, which plays a central role in constructing MLOps system. And also because our company mainly focuses on manufacturing applications, and so think this talk the MLOps strategies for manufacturing as well. So okay, so according to the McKinsey's report, global annual potential of AI is about $15 trillion annually until 2030, and supply chain management and manufacturing takes quite a lot of portion out of those 15 trillions, which ranges about from 3.6 trillions to 5.6 trillion. So it's quite big. So we have a lot of potential value at stakes in manufacturing. So naturally, many manufacturing companies actually trying to leverage the power of AI to their operations, right? But at this point, out of the attempts to achieve their initial targets through AI, it's about only 16% is successful, right? It's pretty low still. Yeah. So why, right? Why so low success ratio? So we think that there's no one fits all solutions in manufacturing applications. So different approaches are necessary to tackle the diverse problems in many manufacturing companies, or even within a company, right? So this is usual workflow for developing and deploying and operating AI models, right? But compared to some benchmark problems, which is very well defined, if you want to apply the machine learning or AI to improve your productivity in manufacturing, you really need to start from the make a definition of the exact problems, and then you need to create quite specialized AI, usually by embracing the domain-specific knowledge. So in short, to solve the real-world problems, those customizations and customized AI is inevitable. Okay, and that's quite difficult. I would like to quote Anna Karenina principle. So in Anna Karenina, the novel written by Leo Tolstoy, the novel starts like this: all happy families are alike, okay? But each unhappy family is unhappy in its own way, right? This means that usually failing just one condition is enough to become unhappy, okay? So you need to meet all the conditions to become happy, right? If you apply this to manufacturing AI, you need these three. You need to meet all the three components at once. So you need a good data infra in IT and operational technology point of view. And you also need a pretty good machine learning infra to manage machine learning life cycle. And also, as I mentioned before, you need some specialized AI by embracing the domain-specific knowledge for the manufacturing. Okay. So let's talk about the machine learning infra, which is our main focus in this talk. So let's take a closer look at like machine learning infrastructure. Okay. So, well, so apparently, because this is a machine learning applications, machine learning models is let's pointer here. Okay. So the machine learning ML model, machine learning model, is apparently a very important like component in machine learning applications, of course, right? But on the other hand, it's still a very small part of the entire like systems, I should say. There are lots of other components in establishing a working machine learning like systems. Okay, you need to like some configuration management. You need to a component to do a data collections, feature extractions, data validations, like serving infrastructure, monitoring, and so on, right? So this actually, this like picture is from the invaluable like paper written by Google in 2015. So I recommend this paper to everyone to read. Okay, it's called like Hidden Technical Debt in Machine Learning Systems, and I think this paper actually made many people to think about what we now call an MLOps. Okay, so what is an MLOps, right? So here comes the concept of the MLOps, which is an AI operating systems for machine learning lifecycle management. Okay, and that will empower the companies to unleash, the AI's full potential, I think. So, or you can also say that MLOps is like a set of like practices, right, that aims to from developing and deploying and like the managing operations of all these reliably and efficiently, of course. So if you take a look at the like MLOps trend, according to the Google trend, like interest on MLOps becomes higher and higher as time goes by. So Kubernetes is there, Jupyter, TensorFlow, that paper I mentioned. And I believe that the growing interest in MLOps is closely related to the like increasing recognition of AI's value in real life or real work. For example, like ChatGPT, GPT-3, like data-centric AI. All of these like approaches are basically very closely related to the real-world application of AI, right? And I think it's closely related to the emergence of the MLOps. Okay. So MLOps is kind of like, I don't know, still unfamiliar concept, but I think we all know what it is. Okay. So on the left side, it's like a manufacturing process, like car manufacturing process in early 20th centuries. So like General Motors usually produce like 2,500 like units of a single model in a year, okay, through this process. And like fast forward to 2020, like Toyota manufacture usually like 9 million units across like 80 different models, okay? The process is usually like they are like essentially the same process, right? It's car assembly process, but at the heart of this like improvement is that the improvement in the speed, right? First thing is like the improvement in the speed, which was done by the robot automations, right? So automations plays a lot of roles in this like dramatic increase in productivity, right? And the second one is ensuring quality at every stage, right? How can you do that? It's through the standardization, right? If you standardize like every step, then you can ensure the quality of the outcome of that step at every every steps. So in turn, it will lead to the overall the over productivity can be increased. So as I mentioned, like by standardizing and automating ML development and deployment and operations, we can boost the productivity, right? And efficiency, of course, for ML developments. And that's what MLOps is for, basically, right? So yeah. So like at the heart of this like MLOps, we have like Boyd's law of iteration, which states like speed of iteration beats quality of iteration, right? So seamless like connection between all the steps within the ML lifecycle is really important thing to boost the productivity. Okay. Right. So as I said, it's not a linear process, but the like ML lifecycle is like rather iterative one with like continuous feedback, right? If something doesn't work, you need to go back. If your model doesn't like work, if your analysis is not working, you need to go back and check the data, right? And yeah, it happens in every steps in ML lifecycle, right? Constant feedback and like iterative like iterations. Okay. And finally, I want to talk about this part of the like MLOps, which involves like model training pipeline. Okay. So yeah, so the thing is like machine learning models usually need to get updated with new data and new parameters, right? So to retrain the model, the operators here, the operator detects that, okay, this model needs to be retrained, right? Then he needs to contact the author of the model and ask her or him to retrain the model, right? So this approach can slow down the entire like DevOps loop for the application significantly. Okay. So to establish like more efficient operations, so data scientists, instead of just like handing out a trained model, they are requested to hand out the training pipeline. Okay. Training pipeline, which means that okay, I can say so they are requested to provide an entire training pipeline that can produce trained machine learning models. So it's like an application to keep creating the machine learning models, right? So if you take a look at here, it's now a kind of applications. This was provided by the data scientist, but now the operator doesn't need to contact the data scientist, but just like pressing some buttons in this machine learning model training pipeline with changed variables and like data sets to produce a new model, and it can like accelerate the life cycles, right, dramatically. Okay, so this is all good, right? So basically, operators can train new model without involvement of the data scientist. in this scenario, right? So this is all good. But like, okay, so introducing this like model training pipeline basically impose additional burdens to data scientists, right? So data scientists are already like fluent in Python and machine learning libraries, so they are really good in developing a model architecture and carrying out data analysis to make a model. But now they should be able to like providing a data, the model training pipeline, which actually is related to the infrastructure, underlying infrastructure as well, like Kubernetes and Dockers containers. And also, they should be able to write a pipeline definition, usually like in Argo workflow, like Airflow, Kubeflow, Luis, and others, right? So compared to the past, data scientist role got expanded a lot, right? They need to be data scientists and kind of software engineers and a little bit of infrastructure engineers as well. So it actually imposes a great pressure to the data scientists to make a successful MLOps system. Okay. So like we have research like method create like a model training pipeline for data scientists, because data scientists usually like JupyterLab, which is very flexible, but usually inadequate in creating some well-defined program like model training pipeline. So we actually added functionality to the JupyterLab as a JupyterLab extension that actually you can specify like dependency between the code cells, and then you can pull up your remote resources like from your like data lake or model registry to test your data pipeline before like deploy the data pipeline to the production. So things like there is a way to to supplement those difficulties by providing good applications in this case. Okay. So if you are more interested in like technical like perspective of this process, I mean, just find me at our booth and we can talk about it more closely.